everybody, my name is Tatiana and welcome to my video series on OTF Studio thin film software, a modern, smart and powerful software for designing, characterization, reverse engineering and monitoring of multi-layer optical coatings. One of the key prerequisites to producing high-quality optical components is accurate knowledge of optical constants of thin film materials. Optical constants of layer materials can be dependent on deposition technology and on process parameters. In this video example, I will demonstrate how to perform optical characterization of a titanium monolayer using OTF Studio thin film software. In this video example, I will demonstrate how to characterize a titanium film on BK7 substrate. The planned thickness of the film was 140 nanometer. The film was produced using electron-beam evaporation, and the substrate temperature was 230 degrees during the deposition process. In my disposal, I had transmittance and reflectance at quasi-normal incidence. In this picture, we can see comparison of measurement data, transmittance and reflectance, and the data of the uncoated substrate. I open my OTF Studio project configured for this characterization problem. Here in the layout, we have measurement transmittance and reflectance, and transmittance and reflectance of the uncoated substrate. And reflectance minima are on the reflectance of the uncoated substrate. One of transmittance maximum is on the substrate, and another maximum is below than transmittance of the uncoated substrate. It indicates presence of absorption in titanium film. In the environment panel, everything is already loaded, measurement data, and BK7 substrate of 1 millimeter thickness. And these two checkboxes means that reflectance and transmittance are calculated with the substrate backside. First, we need to specify a model for refractive index and extinction coefficient. In the spectral range 400–1100 nanometer, we can take Cauchy model for refractive index and exponential model with 3 parameters for extinction coefficient. In the Cauchy model, we have 3 parameters. In the exponential model, we have 3 model parameters, and 1 more parameter is film thickness. Then we can compose a discrepancy function which estimates the deviations between model spectral characteristics, reflectance and transmittance, and corresponding experimental characteristics, reflectance and transmittance. And we will minimize this discrepancy function with respect to 7 model parameters, 3 for Cauchy model, 3 for extinction coefficient, and film thickness. First, I open optical constants plot, layer plot in view ribbon, place it under fitting plot, and separate refractive index and extinction coefficient plots, and place them side by side. Then I focus on the layer model builder and specify starting thickness 150 nanometer and constraints 100 nanometer, 300 nanometer. Then select Cauchy normal model. Normal means that A and B coefficients are not negative, and exponential model for extinction coefficient. Then start. This is a global search for parameters over the parameters range and over thickness range. And immediately we can see excellent fitting and reasonable dispersion dependencies of refractive index and extinction coefficient. And final polishing is still running, but we can see already that thickness obtained is 142 nanometer, and this is very close to the planned thickness of 140 nanometer. Now it's close to finishing, it's finished, and we can see resulting thickness value. And we notice that discrepancy is about 0.6%. It means that average deviation, very roughly, average deviation of experimental and model data is about 0.6%. If we would like to compare obtained results with reference results, for example, titanium from refractive index info in the layer material database, we can activate compare tab, choose layer materials, check titanium from this database, and we can see two refractive index curves. The pattern of the curves is very similar, so it's indicating the reliability of the results. Now I would like to stop compare, simply release the tab and save layer material on the measurement grid, commit, give a name, for example, titanium from reflectance transmittance, commit, and the values are already in the database and I can use them for further design or reverse engineering. Another possibility is to characterize this film using ellipsometric measurements, psi angle at different incident angles and delta at different incident angles, and depolarization, which means that the measurements were performed with the substrate backside. In this case, it's important to check ellipsometry checkbox on the environment panel. The default value for this checkbox is unchecked. So the next step, I focus on the layer model builder. Specify starting thickness 150 and constraints 100 and 300 nanometer. Kosher normal model, the same model, but for absorption I will take simply non-absorbing model because slight absorption affect ellipsometric angle insignificantly, so we can neglect it in this characterization. And sweep as before, and very fast we obtain good fitting and reasonable results. So very good fitting, and also for depolarization and for delta angle results for refractive index. And if I would like to compare with the previous result obtained from spectral photometric data, compare tab is already activated, and I simply check this previous result, and on the refractive index plot we can see two curves obtained from different measurement data sets. Thickness is now 144 nanometer. This is also in good agreement with the planned thickness and with the previous value of thickness, and this is a good characterization result. Thank you for watching. If you have questions, please contact me and see you in the next video. Bye!